right, really quick, the warm-up is your calculator in Radian Mode. It should be, when you do the AP Calculus exam, everything is in Radian Mode. If it's not, if you borrow somebody's calculator for the day of a test, that's the first thing you should check. They may remind you in the directions, but a lot of students don't read through those directions very carefully, so just so you know. All right, as I mentioned, check your email or your Schoology messenger. I sent you a survey to fill out, but let's look at Schoology really quick. I want to show you what the next 4 weeks are going to look like. So please make sure you're looking up here. So if we go to week 7, I know you guys probably can't see this clearly, but it says the next 4 weeks we'll be focusing on preparing for the AP exam, which takes place on Monday, May 24th at 8 a.m. Unless you are somebody who's taking it digitally at home, then you're going to do it on June 9th. So, but this is for everybody that's coming to Tartan to take the test. For the next 4 weeks, we'll be using this calendar link right here for daily agenda and homework assignments as well as answers. I want you to make sure that that's clear too. So we're going to click on this. I'll show you that in a second. Here's the rough plan for each day that we show up in class. The plan is to review 1 to 2 free response questions each morning, along with a couple of multiple choice questions. And then obviously the attendance is mandatory in the morning for everybody learning at home. The homework is laid out on the calendar link for each practice exam along with its answers. Okay? There will be a 15-point assignment. Now this is a big shift. There's a 15-point assignment each week that's due on Friday that will require you to pick 1 multiple choice question from this week's practice exam and 1 free response question that you have to correct. What you're going to do is you're going to submit full corrections with a description of what of where your error occurred and what you understand now about the question/topic in Schoology. So let me show you what we mean. And this is something that there's a lot of freedom for you to, if you're somebody that's just going to do the bare minimum, just pick 1 multiple choice question, 1 free response, and say this is what I did wrong, you're not going to be ready for the AP test. All right? So here's what the homework is for this week. If I click on that link, we have our calendar. And I tried to set this up so it's easy to view, just so you can see here. So today is the 26th of April. And what do we have in class? We're going to review rate and accumulation free response. And then you click on this link, and your goal is to do the multiple choice no credit of practice exam 1. That's 28 questions, I believe. It's all multiple choice. And then on Wednesday, Thursday, you're going to do the same practice exam, but you're going to do the calculator part, which I can't remember how many questions that is. I think it's 15. And then notice there's a link here. You should start chipping away at the free responses throughout the week. So each week, we're going to do a full practice exam as homework. All right. Now, what does Friday look like? You can see Friday here. I just have submit review week 1 homework to Schoology, and then this is the homework, what I told you. Pick 1 of the multiple choice, 1 of the free responses, correct. So let's take a look at when you use this link. Here's practice exam 1, and you do have to read the directions. Okay, Calculus AB. What you should do is you should follow this timeline. We want to just try to get it as best we can to be like a real exam. There's 28 questions. Notice it says no calculator. All right, so you can do the first 20 questions. Roughly, that's about 2 minutes per problem. So you don't have to write this all down. You're just going to put on a separate sheet of paper, you're going to put number 1, show your work, and my answer choice was A, B, or C, whatever. All right, and then go through the 28 questions. You can see here's the 28th. And then you get to the next section. So then we have 17 questions, which is 50 minutes, and a graphing calculator is required. To get the true effect, you want to know when to use a calculator and when not to. All right? And it's all in the directions. So then you'll answer those. And when you get to the end there, so here's the last question. Then we get to the free response part. So there's 6 free response questions. Sometimes we'll do one of them in class. And if you take the notes, then you don't have to do that problem unless you want to redo it and just see if you can kind of redo what we did in class. But here's problem 1. Notice it says a graphing calculator is required for some parts. And so this is the calculator part of free response. There's 2 questions, 30 minutes. They say about 15 minutes estimated for each free response. All right, so here's number 2. And then when you get to number 3, it's a new section. The remaining 4 problems are no calculator. Okay, so 3, 4, 5, 6 has a slope field in it. So once you're all done with that, at the bottom, here are the answers. Okay, so if you do this, it depends on if you want to do the homework and then correct it at night, and then just have everything set. But you should go through and just fix as many as you can. As we saw before, there's going to be some problems that even knowing the answer, you still have no clue, and that's fine. Right? That might be something to bring to the afternoon session and talk about. Hey, Strub, I got this problem wrong. Can we go over it? I don't understand it. And we can do that. But here are all the answers for the multiple choice. And here are all the worked out solutions for the multiple choice. So they tell you how to do it. And even by looking at some of it, you might look at it and be like, I have no idea how they did that. Right? So we have all the worked out solutions for multiple choice. And is this free response now? Here's the free response. All the answers for the free response, full worked out solutions. Okay? So what are you going to do then? On Friday, you're going to click on this, and you're going to submit a picture of one multiple choice problem that is corrected with a quick explanation of what did you do, why did you get it wrong, and what do you now know. And then the same thing for one free response. You're going to analyze that free response a little bit more in depth. If you don't get one wrong, let me know. Say, you know what, Strub, I got them all right. And I will be looking forward to that 5 on the AP test that you're going to post. So, I know that sounds like a lot. And then here's the agenda for the whole piece. So, you can plan ahead. If you have more time, you can obviously go through multiple choice and the no calculator and the calculator part all in one night if you want. And then manage your work ahead. You could do all the free response questions in one night. So this is the first week. Look at the second week. It's almost the same agenda. But now we have a second practice test. So we'll have multiple choice no calculator, multiple choice calculator, and then free response. I put in here, just in case some of you are taking that, these are when other AP tests are going to be going on at Tartan. And so you can plan and prep ahead. I understand that this isn't the only class. And if there are, like clearly, I'm not going to know if you do the whole practice test, right? Because I'm going to look at the one assignment that you put in on Friday that has one multiple choice and one free response corrected. And that's where you get your 15 points. It is on the honor system that you're going to kind of work through these practice exams. So think ahead. You know, clearly if you have other AP classes that require a lot of work, you should balance that. And if you don't get through one full practice exam, it's not the end of the world. But if you want to be very well prepared, taking advantage of what we have here will give you that. So let's look at the third week here. We're going to actually do the 2008 practice exam. And then this is the exam that if you would like to come into Tartan, you could take that. All right. Now, I'm still kicking around this idea, and it might be a benefit. If you take the practice exam at Tartan, then I'm not 100% sure on this, so I'll let you know. then you will be excused from our final in class, and I'll use parts of this test to give you a score for the final. Right? If you are not going to take the practice exam in Tartan, then we're going to have a modified exam on the 17th or 18th of May, and that'll be for our final calculus here. Okay. Now it makes sense to take that before the AP test. That's why we're doing it then. And then this last week we have kind of some wrap-up pieces. What else do we want to learn? These schedules could change. If something comes up that's better than what I have, I might change it. So don't work weeks in advance. And I'm not sure if, I might adjust. So anyways, that's where we're at. And then our big thing is our test, AP test is at 8 a.m. on the 24th if you are taking it here at Tartan. Okay? After that, senior's last day, I believe, is the 28th. We're going to have some catch-up, relaxing time, because you guys definitely earned it. And then if we come back, juniors, when you guys are back that next week, we'll find a little bit more relaxing time and just maybe do some Sudoku puzzles or something. Or maybe it's, hey, I got a lot of work in my other class. Let's get that done. Okay? All right. What if you take the practice test but don't want it as your final? That is fine, yeah. So great question. If you take this practice test and then I give you your score, so I'll be grading the free responses over the weekend, and then on Monday when you come, maybe on Sunday I'll email you and say, hey, you know what? Here's what you got on the practice test. Do you want that as your final? If you do, perfect. If you don't like the score, then you could do the final. That's totally up to you. All right. If you take full advantage of this, you will be very well prepared for this AP test. It's a lot. There's no doubt about it. It's a lot. But hopefully you also see that there are things you can skip. And as long as you turn in those Friday assignments where you correct one multiple choice and one free response, you're going to get the full points for this class. Okay? So let's jump into a couple of things here. Now, I don't want to spend a lot of time writing any of this down. We're going to do a free response question together, but I want to talk about the type of free response question we're going to look at. We know most of this. We're making a stronger connection here to something called rate in and rate out or accumulation problems. Now, this fits in perfectly with the unit we just finished because accumulation is the integral. So, again, don't write this part, but what are these types of questions? Well, they're often in context with a lot of words describing a situation in which some things are changing. There are usually two rates acting in opposite ways, sometimes called an out-in question. So a rate of something going in to a rate of something going out. And a lot of times it's like water. Water going into a jug at a certain rate, and then water coming out of a jug at a certain rate. Students are asked about the change of these rates that are produced over time, either separately or together. And that's what we're going to see here today. To be honest, it all involves around the fundamental theorem of calculus. Right? So here's kind of a nice review. Is if I take the integral of a rate, remember this is accumulation, what's left over is your total amount. And again, we're going to write this later, so don't write anything down. But when we think of it, sometimes if an interval is acting together, it's basically taking the integral of your rate going in versus the rate going out with respect to time, from some beginning to an end. Okay, so you'll see that come up here. The rates are fairly complicated functions. They look scary, which is why this is often done on your calculator. And what you should do is you should store these equations in your editor or in the y equals, and that's what I'm going to show you today. We've done a little bit of that, but that's where we're really going to use it today. So then you should use your calculator to do any graphing, integration, or differentiation that may be necessary. A lot of times, this is another way to write what was just on the other piece. So if let me show you this really quick. took this part right here, minus f of a, what if I added the f of a, which notice a is the starting value? What if I added f of a over to this side? That'll tell me how much total is left over at the ending amount. Right? Because a is the beginning, b is the end. So if I want to figure out how much is total at the end, I take the starting amount plus the accumulation from a to b. And that's why how it was written here is the same thing as here. So if the question asks for an amount, look for a rate to integrate. The final accumulated amount is the initial amount, notice x of 0, that's our first amount, plus the accumulation from time 0 to whatever our ending time is. So that's the initial amount plus the accumulated change. A lot of times that's the given condition. They always say at time 0, there's 200 gallons in the water.
Should we step in our notes?
Nope. This is just going over kind of everything we've talked about. What we should write is when we apply it. Okay? I'll post these notes, so if you want, you can always go back and look at them. Okay. So the last little part said since this is a big main interpretation of an integral, this can apply in different types of situations. And that's what we're going to look at here. Can you guys see this? Okay, if not, there's a desk here open. This is a multiple choice question, and we want to just practice these. Clearly, we're not going to write down all of this, right? Now, if you just want to sit back and watch and realize that these notes you could get later, perfect. You don't have to write this part down. But it all centers around this idea of either rates of change or accumulation. So let's look at it. Right away, when I look at a table, I think, what are my values? T stands for hours, from 4 to 15. R is a rate in liters per hour. So I already know that R is a rate. So a tank contains 50 liters of oil at time 4. Well, right away, that is my given condition. You know that you have 50 total liters. Oil is being pumped into the tank at a rate. It's important to understand that we have a rate here, which is R, where R of T is measured in liters per hour, T is measured in hours. The select values of R in the given table above use the right Riemann sum with 3 subintervals. All right, so we're going right back to that Riemann sum. And then it says, and the data from the table, what is the approximation of the number of liters of oil that are in the tank at time t? So here's the part that students are often overlooked. What is the approximation of the number of liters? That's total, right? That's accumulation. When you see that, accumulation means there's an integral. And they tell us a time. Where did we go? We went from 4 to 15 of the rate. So we're accumulating from 4 to 15 of the total rate. However, remember how 4 is our start? How many total gallons were in, or liters were in the tank at 4 hours? 50. So you have to add the start. So there were 50 liters to start with at 4.
Why does it also say 6.5?
Because that's a rate. That's how many, exactly at 4 hours, there's 6.5 liters are going in per hour. That's the rate at which it's going in. But this is the start, or the total that we started with at the 4 hours. So now, we need to take the 50 plus the rate from 4 to 15, but they're telling us to use the right Riemann sum. So remember when we made those rectangles, and the Riemann sum was the area of those rectangles. So I'm going to put the 50 just as the plus the starting amount, but then I have to find the area of this rectangle. Well, I have to use the right-hand side, and how far is it from 4 to 7? 3 units. There's my width, and the height is indicated by the right Riemann sum, so we're going to use the 6.2. And then it says 3 subintervals, so now I have to do the next one. The distance between 7 and 12 is 5, and its height is 5.9. And then the difference between 12 and 15 is 3. And its right Riemann sum height is 5.6. Now, unfortunately, you can't use a calculator. So they do expect that you can multiply all this together. So 50, if you need to go do side work, you can. Here's how I would do it. 3 times 6 is 18. 3 times 0.2 is 6, so that's 18.6. 5 times 5 is 25. 5 times 9 is 45, but there's a point, 1 decimal spot. So think of that as really 29.5. And then here we got 3 times 5 is 15. 3 times 0.6 is 1.8. So that'll be 16.8. Then we just have to add all that together. So I would start with my tens. So 5, 6, 7, 8, 9. So I know I'll have for sure 90. And then I'll start with the 0, 8 plus 8. What is that? 8, 17, 17, 6, 23. And then let's do the decimals. 0.6, 0.5, that's 11, 19, so 1.9. And you can add those up. So we should get part C. You can show whatever work you needed to add those up, but the big thing is, okay, this was an accumulation problem that actually tied in the use of the right Riemann sum. So we reviewed more than just accumulation. We reviewed Riemann sums as well. Okay. All right, let's look at another one. So this one is a calculator allowed problem. So water is pumped into a tank at a rate, right there, key phrase. So here's my rate, R of T, in gallons per minute, where T is the number of minutes since the pump was turned on. If the tank contains 800 gallons of water when the pump was turned on, well, notice, that's my start, right? It's hidden. They told you at time 0, there's 800 total gallons. Okay. And then it says how much. How much is accumulation? What is accumulation to us? It's the integral. And It's the integral of the rate that was given, r of t dt, over the first 20 minutes. Okay, so after 20 minutes, which tells me I start at 0 and I go to 20. Now, what's the one thing that I didn't do? I didn't include the start. And we knew that there's 800 gallons at the start. So if this was a free response question and you're allowed to use your calculator, this is the only thing you need to show. And then it's, what's the answer? So we're going to grab our calculator. Everybody do this quick. And I want you to go to y equals and type in this equation. I'll type it in and then show you my screen just in case you can't see it where you're sitting. Alright, so here's what we got, in case you can't see that. 30, parentheses, 1 minus e to the negative 0.16x. So what we did there is we just plugged this in. Now, we don't need a graph, right? What I want to do then is just go to a blank screen. So go second quit. I'm going to clear everything out. And then we want to do the integral. And actually, let's do 800 plus, because that's the initial amount, plus math option 9. And that'll give us the integral from 0 to 20. Now, technically, you could have just typed the equation in right here, right? But the reason why I showed you that is when we get to pre-response questions, you're going to keep using this function over and over again, and you don't want to type it in incorrectly, or you want to use the same function for multiple pieces. So what I'm going to do is hit the vars button. Everybody see this next step? If I need the function, we're going to go to vars, that stands for variables, go over to y vars, and function. And then that'll get you to y1. And that's where we put the equation with respect to x. Okay, that step again to get this part in here is hit vars, scroll over to y vars, and function. And that will get exactly what you plugged into y1. So anytime you want to use y1, we can just keep plugging it in there. Okay, and then hit enter. And that will take the accumulated amount of the rate from 0 to 20 plus the original 800. And notice how all of that was done in our calculator.
Did we find the antiderivative for the last number?
Technically, no, we estimated it. So our calculator found the antiderivative for us in this problem, and that's how we got the total amount. In this problem, we approximated using the Riemann sum. So we didn't have to do the antiderivative because we used the green part, which was the approximation. All right, last one for multiple choice. And again, all of these are similar, but just different enough that you might be confused by them. So a particle moves along a line, so its acceleration for time greater than 0 is given by a of t. So there's the equation. Notice it's kind of crazy, right? We wouldn't want to do this one by hand. If the particle's velocity at t equals 0 is 5, what is the velocity of the particle at 3? Well, let's take a look. What did they give us here? They gave us an initial condition. When t is equal to 0, so think of that as like your starting velocity. have to understand. They gave us acceleration. Acceleration is a special kind of rate. It might be in feet per second squared. They didn't give us units here, so. But what do we know? Accumulation of acceleration gives us velocity. So, if I accumulate the acceleration for the first 3 seconds, minutes, they don't tell us, so we're going to go from 0 to 3. However, what do I need to do? I need to account for what was the velocity at the start of 0, and that was the initial amount. So notice how the context is different, but our setup is exactly the same. It's an integral plus the starting amount. So let's do this one in our calculator. Type this into y equals. Practice the y bars. So let me show you what I did. I typed it into y equals. Make sure you use parentheses. If you're doing it like I did, you put parentheses around the numerator x plus 3. If you don't have those parentheses around x plus 3, it's going to be taking the wrong function. Okay, so now I'm just going to go to a blank screen, and I want to basically have the same setup we did in the last one. I have to take the start, which was 5 plus, we'll go math 9, the integral from 0 to 3 of the rate. And that rate was what I put into y equals. So that's where I use the vars, y vars function, y1, and it always ends with an x. Just don't get confused. Even though it says y1, when we type the equation in y, it was all in terms of x. And now it'll do the work for me. It's accumulating the amount of velocity from 0 to 3, and then adding 5 to that. And the answer is E. So, now that we kind of just saw a pattern, 3 different examples that really use the same setup, let's apply this to a free response question. And at any point, if you got questions, please let me know. What I'm going to ask you guys to do for this one is write the work. I don't want you to take time and write this problem out. That's not super helpful. And again, I apologize. This is the largest I can make these images appear. So hopefully we can see them. So let's look here. The rate at which rainwater flows into a drain pipe. Notice right there, water is flowing in. So that's a rate in problem. Is being modeled by the function r of t. Look at how crazy r of t is. Okay, this is definitely a calculator problem. And it says it's going to be cubic feet per hour. T is measured from 0 to 8. All right, so we're basically looking at the first 8 hours. This is how the rain goes in. The pipe, though, is partially blocked, allowing water to drain out the other end, modeled by another rate. So we have 2 rates. R is the rate going in, D is the rate going out in cubic feet per hour for the same time limit. It's very important to notice that they go from the same time limit. All right, there are 30 cubic feet of water in the pipe at time 0. So if I was doing this problem, I would do this. I would circle rate, and I would just make a note that R of t is a rate from 0 to 8, and then we have another rate, d of t. And then they tell us there are 30 cubic feet at time 0. So there's my start. Now, part A says how many cubic feet of rainwater flow into the pipe during the 8-hour time interval. Flow in, right? Actually, I don't want to use blue. If I'm flowing into the pipe, that's only focusing on the rate R of t, and it says how many feet, cubic feet, which is accumulation. So there is my connection to the integral. How many? If I have a rate and I have to find the amount, I have to undo that rate, which is the accumulation. So our total amount is going to be the accumulation of R of t during the 8 hours. So we're going to start at 0 and go to 8. But what's the one thing that I forgot here? The start, right? The 30. How much did we have at the start? At time 0, we had 30 to start from. And now it's the exact same thing we just did on the other problem. Right? So we're going to take our R of t. Notice it's a sine function, which is why you have to be in radian mode. And we're going to just do 30 plus the integral from 8 to 0 R of t. We will be using R of t multiple times, so that's the importance of putting it into y equals. So go ahead and let's enter R of t in for y1. And while you're at it, go ahead and put the dt in y2. So put the other rate in y2. One of the things I always do is reread what I type into the function or into the calculator, because clearly if you type it in wrong, then everything else you do is wrong. So there you can see I typed in y1 and y2. Okay. Once you have those in, now let's go to a blank screen and let's do this integral 30 plus 0 to 8 of R of t, which you have to remember R of t is y1. By the way, if you were to write y1 here, that they would not accept that because y1 is only true to your calculator. So the person reading this doesn't know you have to use R of t even though we called it y1. So just be careful of that. All right, so let's go ahead and do that. You guys are probably already done with it. I keep screwing up because there's a delay on my my clicks. So 30 plus 0 to 8, y1, dx dt, and there it is. Now, if you didn't get that, there's a strong chance that maybe you mistyped one of the problems. No? Oh, you know why? That I didn't check to see if I was in Radian mode. I bet you I'm not. Did you guys get 70 something? See, well, let me show you this. So, if I type in radians, okay, let me try this again. 10. That's not. Oh. You know why it's not right? The 30. What does the 30 do? Why should the 30 not be here on this one? It's asking for water that goes into. Even though I highlighted that, did it ask for total? No. And I'm glad this happened because that is a very common mistake. I wish I could say that happened on purpose. It clearly did not. I can't. I wouldn't be able to sleep well at night. So when you take away 30 from your answer, you should get 76.570. And you always want to round to with your final answer, should always be rounded to 3 decimals. So, danger or warning, don't fall into that routine that I just did. I was so used to putting the 30 there that it didn't say what's the total amount. It said how much came into the pipe during the first 0 to 8 hours. So that 30 doesn't come into play yet. Not saying that it won't, but it might. Okay, part B. Is the amount of water in the pipe increasing or decreasing at time equals 3? Give a reason for your answer. Well, let's think about that. We have R of T, which is the rate that it goes into, the water comes into the pipe, and we have D of T, or the rate that comes out, and we want to look exactly at 3. What should we do? What do you think we're going to subtract what? You're right. We're going to subtract R of T, but what is T? 3. We have to figure out R of T is going to give me the rate that the water is coming in, right? And then we're going to subtract D of T, which is green, and we have to figure out what is that answer. If we have more water coming in, what do you know about your answer? Positive. If we have more water coming out, it'd be negative. So here's where your calculator comes into play. We don't have to show any other work. I just need a table. And usually what's best is if I just graph this and find the value. So you can hit trace 3 and hit enter. Now you do have to know which function you're on. Alright, so this is the blue function, which is y1. So and you want to take this whole answer. Don't round it. You don't round partial, or you don't round your, whatchamacallit. Don't round your answers until the final answer. So I'm just going to save that one. And then let me show you quickly how to get to the next function. All I did was hit trace and then type the number 3 and enter. Now hit the up arrow. See how it shifts from one function to another? So now here's the value at 5.4. And then I just need to subtract those 1, 2, 3, 5. And to be honest, they don't even need to know the number. They just need to know that this answer that since the rate going out is larger than the rate going in, we know that this answer is going to be less than 0. So therefore, now it's pretty important to answer this thoroughly. The amount of water in the pipe is decreasing at t equals 3 hours. So you don't have to say why, because you just did. The rate going in minus the rate going out at 3 is less than 0, so it's negative. Therefore, it's decreasing. And then you should always indicate at what time. So it's important to put the emphasis on the 3. Okay. Part C. At what time from 0 to 8 is the amount of water in the pipe at a minimum? This is an interesting problem. Okay. The amount, we're looking for a minimum. Another way to talk about that is to talk about the absolute minimum. So what I really need to do is I need to come up with a graph that shows me the total amount. Well, I think we kind of already talked about how to figure out. This is the rate. So one way to look at and find the total amount of water when it's minimum is to look at the equation R of t minus d of t. Now, if I call the total amount A of t, this is the difference of the rates. So technically, when I look at this, this is the rates of the amounts being subtracted.
Is this total amount always supposed to add in 30?
Not yet. Watch what happens. So we could, if we wanted to do all the work, we would have to add up all possible times from 0 to 8 to find that total amount, but that's doing a lot of work that would be tough. So what I want to do is I want to graph the rates. I want to graph R of t minus d of t. So go to your y equals and go down to y3. What I want is I want to take the y1 minus y2. So I'm going to go to vars, go over to yvars and function, and select y1. And I want to then do y2. Vars, function, y2. So now we have to be careful because my graph, see how the highlight or the equal signs are highlighted? I don't want y1 and y2 to show up on my graphs. So I'm going to go to the equal sign and hit enter. And if you hit enter, that'll turn those graphs off, and the only thing it's going to graph is the function y2 minus y1. Now again, I'm not sure what my window looks like, so I might have to adjust my window once I graph it. My window is kind of funky. But let's do this. Go to Windows. Time is your x values. I want to figure out from 0 to 8. I don't need to see anything extra beyond that. And then I'm just going to change this to a regular 10, which is probably where you're at. Now, when I graph this, it's been a while since we've done anything with absolute minimums. If this is the graph of the rates, or this is the graph of what I called A of t, these are derivatives. Notice right here, we got endpoints at 0 and 8, so I have to check the endpoints, but I also have a critical point right here because the derivative is equal to 0. But notice, isn't my derivative negative here and then positive? What kind of point exists when I go from decreasing slopes to increasing slopes? There's a strong chance that that might be my answer, but if I'm checking absolute min, I need to test all points. I have to test the endpoints, which are 0 and 8, and then I have to test this point, which we have to find. So that's where you do your 0 now in your calculator. Okay, so let me show you. Remember how we do 0? Go second, trace. Go down to option 2 is 0. Then we'll have to take a look at it. So then I have to do left bound, right bound. And whenever it says take a guess, there it is, 3.27. Now we want to take that whole thing. So let me just slide this over here quick. So that's that spot. So I'm testing my endpoints and my critical point. And now is where we have to do the integral for all of these. Now the first one is kind of quick. How many total gallons are in, or is it gallons or liters? I can't remember. Cubic feet. How many total cubic feet are there at time 0? 30, right? So that we don't have to do a lot of. And then at heat, didn't we accidentally found this answer. But remember part A was the rate. So from 0 to 8, we had 76.570 cubic feet going in. But then we want the total, so I have to add the 30 to that. So that answer I originally had of 106.570, that's the total amount. So then the next piece is just, we have to figure out the total amount here. And how do we do that? We take the original 30 plus the integral from 0 to 3.271658 of R of t minus d of t. That should have not really bad. So I'll show you how I enter that into my calculator here. So this is what I did. I did 30 plus from 0 to our intersection point. And then we want to do the rates, which was, now notice, I already have y2 minus y1. You could just do this. Y vars function, and instead of doing y2 minus y1, didn't we enter that in as option 3? Because that is the two functions already. You should get the same answer either way. Mm-hmm.
I'm looking for the absolute length. I forgot why can't the bottom of the graph.
Right here? Because this is the graph of the rates. So this is when the rate might be the lowest, but it's not your total amount that's low. So then just really quick to answer the question, at what time is the total amount of the water the lowest? It's not at time 0, it's not at time 8. So then we would have to say the minimum would occur at t equals 3.27. Now is okay to round, because it's our final answer. And the last one is probably a 30-second problem. All right, so this last one, we have 50 total cubic feet of water before it overflows. And that's for any time we are larger than 8. Well, we have to remember we have 30 total gallons or cubic feet at the start. And then if I go from 0 to a new time W of the rate minus the rate in minus the rate out, this total accumulation plus the 30 cannot be equal to 50. Or as soon as it's equal to 50, then we start to overflow. So that's all you need for part D here. Kind of a quick setup, and then we're done. All right, homework tonight is to do practice 1 multiple choice tests, questions 1 through 28, the no calculator, and then chip away at the free response. Remember, your goal is to get that all done by Friday and then submit 1 corrected free response and 1 corrected multiple choice. All right, that's all we have. Have a great day. Adios.